Good morning, everybody. I hope everybody is well. We are going to continue our stream on, I believe, linked list mastery, and it will be on part two. So, in previous class, we have completed up to linked list cycle, and now we are going to start with the question intersection of two linked lists. Let's see what's given in the question. I will reset the code. Okay. So it says that given two heads, head one and head two, and we want to know at what point, basically at what node the two lists intersect. If they don't intersect, we return null. So let's go back to iPad and see what's asked. Let's consider this. And you see, there is no intersection. That means this is head one, and this is head two. So what we do is make this go to null and make this go to null. Uh, Before going, let's say if they don't intersect, that means both of them will go to, let's say the end node will not be common between these two. Like if they have an intersection, there will be at least one point where they share, they, they will share in common. For example, let's say you see that if they are intersecting, that means there is at least one node in which they will traverse together. So let's say I mark head one as this and head two as this. Of course, there is a difference. Let's say this list will be how much long? 1, 2, 3, 4 length long. And this is 1, 2, 3, sorry, 1, 2, 3, 4, and this is 1, 2, 3. One is 4 length long and one is 3 length long. So if we just do 1 traversal, there is a possibility that I will never get to the intersection point. Let's say, so we are going to play on the basis of lengths only. Let's see. Let's say it just starts here. You see that if I start H1 here and H2 here, the H will go to the end before even H1 arrives at that point. So we have to make them equ have equal distance from the end. Like for example, if H2 starts here, then I want H1 to be here before starting, so that once I proceed them by one step, they will point to the same node. So what I will do is find out the length of these two linked lists. So int L1, I will say 0 and L2 equal to 0. Okay, let me full screen this. So what I will do is I will say that both of these, I will try to find out the length of both of these linked lists. First, I will say int, let's say I will initialize the dummy to be the first node, and I will travel this dummy, make this dummy travel while this dummy is available. L1 plus plus. Now we will make this dummy point to B, and I will do the same thing to find out the length of the second linked list. Okay, now we have found out the length of both of these linked lists. Now there can be two cases. Either length 1 is bigger or length 2 is bigger. Let's say length 1 is bigger. That means I have to travel the first head by their difference. let me show this to you. Let's say this is a linked list. So you see, one is 1, 2, 3, 4, 5 length, and the other is 1, 2, 3 length. So if I make this head travel by 2 length, then you see they are of equal distance from the end, like 1, 2, 3, 1, 2, 3. So we want to place them such that they are from equal distance from the end. So we have to travel, make the head of the make the head of that linked list travel, which is further from the end, and how much to travel by the difference of their lengths. So that's what we are doing. So we are saying that if just format this, okay. Now I will say if my first length is greater than L2, so I will mark my uh, I will make the head one. Either I can make the head one travel. I can choose just while, let's say, I will say difference equal to L1 minus L2, and I can say while, or I can just say for. I can just say that head A equals to head A, like making the head A. Even though we should not really change head A, but it's passed by. It's anyways passed. So we are making, now we see that head A and head B are both equal distance from the end. Now I will check that while head A is not equal to head B, like there will come a point they will meet. And of course, they cannot be null pointer. If they don't intersect, then head A will go to null pointer without ever, like let's say there are two linked lists. One is longer, one is shorter, but they never intersect. So even though after making this travel, so they share equal distance from the end, they will still will never intersect because they will each get to null before even ever intersecting. So while the pointer is available and it's not they are not equal, I can just say head A. I can just say dummy equal to head A. Mm, I can just, yeah. Now either they will be equal or they will be null. I can just return head A because if they are equal, it will be returned. If they are not equal, it will not be returned. The other case will be the same. Just we will now travel head B, and this really doesn't matter which one we do. And in the end, it doesn't matter which one we return. What if they have no difference, like equal? In that case, the difference will be 0. So I can put an equal to sign either here or on the top. It really doesn't matter because they have no difference. That means the difference will be 0. This for loop will not run. And in the end, even though this will never be the case, I can just return, say return null pointer. Or I can just say, yeah, let's try running this. Okay, it's giving wrong answer. Okay, no intersection, but we intersected at 8. It's the first test case, right? So, okay, this should be less than equal to, right? Yeah, I'm re-explaining the code. Uh, so first what we do is find out lengths of both of the linked list. Now we make that head who is further travel the difference so that both of the heads are equal distant from the end. Now we make them travel together. Either they will intersect together or both of them will go to null together. If they intersect, this will come out to be true. I mean, this will come out to be false and it will break and I will return. If this becomes null pointer, this will be false. Still we return null pointer. In the second case, we just do the opposite. The same code. I hope you understand. Let's try submitting this. It gets accepted. This code will be available, of course. Let's try to solve the next question. Remove linked list elements. Okay, let me just reset. It says given a head of a linked list and an integer var, remove all the nodes of the linked list such that and return the new head. Okay, so we are given a value. Every time we encounter that value, we don't want it in our linked list. There are two different ways of dealing with this. I mean, two ways to handle edge cases regarding this question. Let me explain you. Let's say, let me take this example. 1, 2, 6, 3, 4, 5, 6. I mean, it's asking us to return, remove 6. You see, first I will go to 1 and I will check if it is equal to 6. If it is equal to 6, uh, or I can check the if the next is equal to 6, then what I will do, I will make this point to this. What if there are multiple? Then I will put a while loop then. For example, let's say we have this. I'm checking that once next is 6, right? So I will make once next point to this, but it's again 6. So I will make once next point to this. It's again 6. So I will make once next point to null pointer. But what if the head is itself the value that I want to remove? That's why we play a special trick. We take a dummy node with some weird value. It doesn't matter which value we take. Let's say I take 5 and then I make this point to 1 and then 6, 6, 6. Okay. Now I check that if dummy is next is the value I am. This 5 is you can take any value, it doesn't matter. You can take 10, you can take any value that is out of the bounds. I mean, not expected to be an element inside the linked list. Doesn't matter. So what we do is, let's say its next is pointing to some value that is not supposed to be there. Then we do what we do, we jump. If it's still, we again jump. So this kind of handles the case where, and in the end, we return the next of this. I'm showing you this through code. It will make sense. This is basically a way to handle that. What if the head is itself null? So we make a new node. Dump is equals to, I can just call this function. I think I should call this one. It's better. I can put any value, it doesn't matter. Let's put 5 and our next will be head A. So we are making a dummy node that points to head. Okay. And now we check while arrow next, while dumps next is available, if while and dumps next. So what we're doing is if while dumps next is available, like I have something to point to, I am saying that if dumps next, like the next element's value matches with the value I'm supposed to remove, I'm just linking my next to uh, the next's next so that it skips it. And in the end, we return dumps next. Okay, let's see. Um, should I say new list node? Okay, time limit exceeded. Okay, if any of this is not true, then dump equal to. Of course, it cannot remain taking forever, right? Okay, there is a possibility that if dumps next is null. It's a dump, and let's say if head is itself null, then hmm, can I say if dumps next is null pointer? Okay, if dump becomes a null pointer, right? Okay, what if 5 is the wait? So I shouldn't. Let's go back to our original definition. Okay, let's see where the problem is. Uh, while dump arrow next. Is this not working? Like dump arrow next should be head. That is given to us. What if head is null? So let's remove this bad test case. Uh, am I making this node wrong? Should I say it points to head? There is something wrong. Let's think. Uh, okay, let's do one thing. While let's make this point to head. Okay. Can I go back to the code? This was the last code I submitted. I think we're doing the same thing. Are you? There are a lot of checks. Let's try it again. Still stream running well. Let's try it again. Still stream running well. So let's start. We will use the normal approach only. We'll try to debug it somehow. Right? I will say while Wait. So it has found two sixes. Okay, why am I returning dump? I should return. mm, Silly mistake. Okay, two, three, four, five. Okay, for one I forgot for some reason. Okay, we are back to our original code. So first we said is let the dump be a new node before the head that it point to the first node, and we have kept a copy of this. That's it. And now we are saying that while this dumps next is available, we say that if dumps next is available and dumps next value is our val, then we what we do is make it jump. I don't think we'll need a lot of conditions here. I think we also need this dump as well because sometimes hit can be null. Uh, yeah, hit can be null. Let's try submitting this. Okay. Uh, why do we need this dump condition? Yeah, because you see, when I'm traveling, sometimes it can become because we are not putting a further check, right? So what we are doing is I should have took out that mistake. But you should I should not be returning the dump. So what we have done is let's take this example 1 2 6 3 4 5 6 and let's say 5 is our dummy node, right? And so is you. Now we are saying that you see now we are saying that while this dump is available, like dump has not reached the end, and dumps next is also available. Now we are checking while dumps next and next value is val. like you see, then we can just make it jump. So you see, at the first we compare this 1 to 6, 1 with 6, it fails. So we just go dump is equals to dump text. Similarly, this is how the dump will go up to here. And now it will check that dump's next value is that. So what I will do, I will make this point, I will cross this, and I will make this point to this. What if there was another 6 here? It will still do it again. Okay, so next we come here, 5, and its next is null, so we make this point to null pointer. Now you see, in the end, dump becomes the null pointer. That's why it was giving me errors. Sorry, I took a lot of time to debug. But U has stayed here. What if it was a 666 case? You understand that this 5, let's say this is the dump, and this is the U. Now you see it use next is null. So dump will ultimately, this 5 next will ultimately point to null pointer. And dump will be this null pointer. But you see, now use next is also a null pointer. And we are expected to return a null pointer only. But U never becomes null pointer because it's a dump. It's that node we have kept just to keep safe. And from that position, we will start comparing. Okay, let's go to the next question. Reverse linked list. There are multiple ways to do this, but this will uh, form the basis of a lot of other stuff. Remember the code we remember the approach we followed while merging two linked lists, two sorted linked lists. We said that our node will be the answer to the rest of the world, and it is supposed to return me a pointer. We will solve this by that approach. Of course, there is a three-pointer approach as well, but let's try to think of the recursion first. What I will do is I will imagine that the reverse list. So list node, uh, basically my head, whatever my head's next will be null pointer, and I will expect that the rest of the reversal will be handled by reverse list if I pass it the new head. I hope it makes sense. So I will say that uh, let's call this reverse list, right? And I will pass head arrow next. So this will reverse the rest of the list, right? And it will return me a pointer. Uh, I mean, this reverse list will return me a link, and I will link that to my current head. And I will say head arrow next equals to null pointer. But no, this will not be the case. I'm showing you what I'm thinking. This will not. So let's say this is a list. Now I want this is the head. I'm passing this entire section, and it's supposed to return me first reverse by itself, and then return me this head, right? And after it has returned me this head, I'm expecting all these reversals have completed. And I will say that heads next. Sorry. So hmm, heads next should be head. So what I'm doing is I know this is the head. This is the heads next. I'm saying that this next will not be this. It will not be this. It will be this. And now I am supposed to pass uh, mm, think a little bit more. First, I will say, let me find out the new head. I will call this with head arrow next. I'm expecting this to reverse. I'm expecting this to reverse everything except this and return this new head. Right? All I have to do is do this linking. Yes. So what if heads next is a null pointer? Let's say I'm sitting on the last node. right? If I'm on the last node, I will just return myself. Let's think about this a little bit more. Let's see. Uh, Mr. The end. What kind of test cases do I have? I don't see any progress. Uh, what if it is null itself, right? Like there is no playing with next. Set head equal to head's next is head. Ah, I have to set this next to be null pointer. Wait, I hope I'm audible now. I hope let's get back. Let's resume our activities. So we were solving this question. Remove linked list elements. I believe we have successfully solved this. Mhm. Let me connect my iPad. Yeah, I don't know why the camera is so much zoomed in. Still not sure. I hope it's okay now. Anyways, let me just let's go to the next question. Okay, have we completed the reverse linked list submissions? Have we just submitted now? No, we have not submitted this yet. The last submission was 2 years ago, I guess. Okay, this got accepted. So basically, what we are doing is, let me explain you this recursion. I will also do is my audio still there? I did not want to stop that. Yeah, my audio is still working. Let's see. So what we are doing is, let's say this is my linked list, right? Now we are saying that this is the head. We are saying that, okay, I will just take care of one of these elements. That heads, nexts will be head. So this got reversed and this got cut. But before cutting this, I'm just saying that solve the rest of the question. And this uh, is saying that, okay, solve the rest of this question. It's saying that solve the rest of the question, and it's saying that solve the rest of the question. Now it says that, now you see at this point, solve the rest of the question. You see, this is the new head. This is where the head comes. Now you see the heads next is now none. So like here, you see, not this question. Yeah. Now you see that heads next is now null pointer. Now when heads next is null pointer, it returns head. So it returns itself. So you see at this point, uh, it returns itself. Now after returning, what we are doing that I'm saying that heads next. After we got this new head, we are saying that heads next. So this was the head in this stage. This was the head in this stage. And I'm saying that heads next is equal to head. So heads next, new head we have already got. That this is the new head. Okay. And I'm saying that heads next. So this link I just established after getting this new head, right? Like this new head's address is returned to this node. And I'm saying heads next is this. After I got this new head, right? And now I return this new head again that I got from this iteration. I'm not playing with the new head, right? Now I'm still saying at this stage, after I get this new head here, I'm saying heads next is again this, right? At this stage, after I get this new head, which is from the end, I say that again, this heads next, next is this, right? Now, let's say we did this. Now I did one mistake that I was pointing this head to the null pointer. This is not the case. After assigning heads next, next, I have to say that heads next is a null pointer in the end. Like heads next will be null pointer. I hope this makes sense. So if head is null pointer, we return null pointer. That's just the base case if null list is given. If heads next is null pointer, that means we are in the end. We are returning this head. So this will be the new head across every sub-level return. Now we're saying that after we get this new head from the end, I'm just, let's say I've passed on some stages, and now I'm saying that I've got the new head, the rest of the links are working. Now I'm just reversing my own link. Because after that, the new head has done all the work. I hope I'm making sense, right? I don't know why the quality of this camera is so bad. Like still the normal camera, I hope. Should I put this a little far? Okay. Let's do the next question now. It's palindrome linked list. It says that given the head, return true if it's a palindrome linked list. Well, one way is traversing it, storing it in an array, then reversing it, storing it in an array, and compare those two arrays. I'm sure there is a follow-up. Yes. Could you do this in order n and in constant space? So we are not allowed to use an extra space, extra array. After solving this, I will do this reverse linked list again through three pointer method. That's the standard approach. But let's try to solve this question first. So we have a linked list and we want to see if it is a palindrome and we don't want to use any extra space. The first approach is if you are allowed to use extra space, which is this is an easy question, so we can. But uh, so the approach is traverse it, store the elements in an array. Of course, we can first calculate the length of the linked list by making the traversal, making that size array, traversing it again, storing in the array, reversing the linked list through the recursion approach possible. Then also there is a print reverse method that helps you get the elements in reverse fashion. Like let me show you. Let's say vector forward. What I will do is let's say void populate, and I will just pass in the head. Observe what I'm doing. I will just say that do what thing? One thing. If head is not empty, head yes head. So populate forward or push back head val, and then I will call populate for head arrow next, right? And after calling this populate, I will do the same thing but in the backward, like while returning through the recursion, right? If head equal to null pointer, I just return, do nothing. Now you see, I just call this populate function on head. Let's try to print this. X through forward. I should just leave a space and then I can give a C out and I can just bring the backward as well. I hope I'm making sense. I will of course have you try run this. Oh, I'm supposed to return something. Hmm. Okay, reversed, not backward. Just return false for now so that it compiles. Okay, you see, we have populated both of the arrays through reversed, the reverse and the forward. I'll tell you how this backtracking part works. Let's say this is my linked list 1, 2, 3. Let's say 1, 2, 2, 1. Make it a palindrome. First, I go to the forward. I say, okay, forward, take 1 and call this function for 2. The 2 will say, okay, forward, push 2. Then it again calls for populate for this. Okay, forward, push 2, done. Forward, push 1, done. Now you see, at the last stage of forward, like first populate will be called for 1. Let's make this index, give this indices 0, 1, 2, 3. First populate will be called for 0. This will push 1 into the forward, right? And then it will call for populate 1, then populate 2, 2, and populate 3. Now populate 3 will push again 1 into the forward stack. And after this populate 3 has been finished, then it will push 3, I mean the 1, the last one into the backward. You see, this gives this makes a separate call stack. And that when the last pointer, like which is of index 3, let's say, the populate gets executed, now only we are pushing the head dot value to the reversed. So you can say if you can just say that uh, 0 I less than n will be any of that size. If let's say reversed I is not equal to forward I, return false, otherwise return true. I don't need to do the C out part. Let's run. This is of course using extra space, still order in operation. Let's try to submit. I've not solved this before, this question. Have I submit this before? Here's my submissions. Yeah, this is the first time of me solving this question. Uh, let's try to do this without using any extra space. So what is my approach is, I will first find the middle of this linked list. Then from that middle, I will reverse the rest, get that head. And middles Next, I will make it point to ground and I will check from the end. These two equal, okay. These two equal, okay. These two equal, okay. If any of them fails, return false. Let me show you this to you in iPad. So let's say this is my linked list. 1, 2, 3, 1. I will find out this middle. Okay. I will store this in some temp. I will make this point to ground or null pointer. I will send this and say reverse the rest. So okay, reversal has been done and I have this new head and I have n head and this head we already had and I will start comparing. Head equal to new head, good. Head equal to head dot next, new head equal to new head dot next. At any point before finding they are null pointer. Okay, this works for even length linked list. What about odd length linked list? 1, 2, 1 maybe. So 1, 2, let's say 1, 2, 3, 2, 1. You understand if I use the rabbit's turtle system. So initially R and T will be here. R will go here, T will be here. R will go here, T will be here, right? And then now R's next is null pointer, so R cannot go. So you see we have reached here. Now you see if I do this to ground and I reverse the rest and get this new head, and let's say this is head. Okay, okay, one of them has become null. That means it's an odd length list. Then we just say it's palindrome because you see there will be maximum one more element left, and that is the middle element, so we consider that as palindrome only. I hope you understand. Let's try to code this solution. So we're not going to use any populate function. We will first try to find out the middle. Turtle will be the middle, and rabbit will also be. If you don't know about this rabbit turtle method, please refer to my earlier stream, that is linked list mastery part 1. Okay, and I will say while rabbit is not null and rabbits next is not also not null. I will say rabbit and turtle. Okay, uh, you understand that this at the end this turtle is the middle. So I will say list node star temp is equals to turtles next, and I will say turtles next equal to null pointer. Now I will call the reverse function on this temp and I will get the new head. So can we use the reverse linked list method? Yes. We don't need the populate for function. So we are using this reverse linked list method, and I will call this reverse linked list method with this temp, and this returns me the new head. back head, we can say, right? Now we have the back head, we have the head. I hope we have not destroyed head anywhere. Yes. Now we say while back head and head. Should we make this? Let's make new. We don't want to destroy back head and head. Let's say start head and end equals to back head, right? And we say while start is not null and end is not null. We say if start val is not equal to end arrow val, return false. Otherwise, start and so will, and we will return true. Let's try. So running this. Okay, we have declared robot. Anything else? Okay, start equal to head, end equals to back head. Okay, this returns me true. Why? Okay, what's the middle? Okay, let's make a new test case. 1, 2, 1. Let's see if it is doing well for every case other than 2 length. Yeah, 2 length, it's not working. 1, 2, it's not working. Why? Let's check. So the rabbit will point to one's end will point to null. The reversal will return the head itself. Let's try to print the first node's value. Turtle's value is 2, even though it should be 1. Yeah, I think it's a problem for only 2 length. Like in the first step only, turtle moves by 1 step and rabbit moves by 2 steps. Hmm. There are multiple ways to handle this. One is if rabbit's next is null. Like one way of doing this is finding the, if it is an even length, finding the middle, but the floor division middle. Like if there is 4 nodes, I want one to be the 0, 1, 2, 3. I want tail to point to the first node, not the second. Like in case of 1 to 2, 1, should I, I think I should scale tail one step back. Yeah, that will be helpful. Like tail, I should have a tail previous, I mean turtle previous. That is a better approach. So what I will do is, uh, previous equals to null pointer. Now before sending turtle to turtle.next, I will say turtle equal to, uh, I will say that previous equal to turtle. Right now, I will just say previous next. I will make it to 10 and previous next will be null pointer. Previous value I will, yeah, that solves it because basically floor division we're trying to get. Okay, we have a null pointer exception. Temp is equals to previous arrow next. Okay, what if head only has one element? Yeah, that will fail. Because in that case, there is no previous. I can just say that head arrow next equal to null. Return true. Mhm. Yeah. If there is only one node, there is no, what will I reverse? You see that in the previous, next will be null pointer. Now, if you pass a null pointer and tell it to reverse something, it will just return a null pointer. And if that doesn't contain any value, right? Okay, this gets passed. But you see, we are changing the data structure, right? Is there a way to do the same question without using any extra space and you are not changing the data structure as well? It's impossible. But like impossible without any extra space. Like there are ways to use extra space. One is you use the array to store, or you can use the recursion stack space. Like remember in the reverse linked list, we were using the recursion stack space in order to keep track of the new head. So we can do a similar approach. Like let's say we have reached the end. Then I will compare it to a global head. And then I will keep on passing. So I can do, uh, let's try our best. Is there some bad sound? Okay, it's working. Let's try to use the recursion stack space in order to solve, let's say, G head, right? We will not require this. I think reverse, not list, let's say reverse, it's a recurrence. And I will pass in head, and I will call if head arrow next, return, will just return. Otherwise, I will check. Hmm, is heads val. Now I will just recurrence. Now after we are done with this recurrence, I will check that if head arrow val equal to G head. This should be bool. It's not equal to, I just return false. Otherwise, else they are equal. That means G head, G head next. And if none of them has returned false, then I return true. So what I will do is, no need of this jargon. I will just say that G head to head, and I will call that recurrence with head. I can just return this. Let's try. I'm sure there will be some errors. Yeah, return. Okay, if heads next is null pointer, that means I'm on the last node, right? Then I will check if heads value. Mm, if heads next, if if heads is not equal to null pointer, then only I call this recurrence. There's no point of me to return. If it is a null pointer, then I will just check for those conditions. Okay, okay, this should be arrow. Okay, so 1 2 returns true. Okay, so this is running well. 1 to 1. So G head is head, and if called recurrence with head. So at first, what we'll do, heads next is not null pointer. So I call recurrence head on next. Now two's next is null pointer, and G head is still at 1. It's not equal to, so it will return false, right? And why is it returning true? Should I print head value before returning false? Let's print. And okay, so head's value is 2, it should be, and G head's value is 1, and they are not equal. So return false, right? G head dot next. I should not return true here because that's only one of the conditions. Look, I should return this, but I have to return something. Yeah. So if its next is null pointer, so from the end only we are trying to. So why is this? Should not return, but then that function will probably not run. It is expecting some return at least. This should be a return, but let's think again. So we have reached the end. It is not null pointer. I want to proceed next. Okay, I can just make global good is equal to true. I can just say good equal to false, right? No need for any return. And return good. Let's use this test case because at any point I find anything bad, I will just make the global good to be false. There is no way to prevent me. I hope you get this. I will explain this again. So what we are doing is while backtracking, We are modifying the global head, which is from the front, and we are checking. Like the recursion is done. Now we are in the end. Now we will check. Its next is now we know it's null pointer. Now we are checking this with the global head. Good. Then we are doing, if it is not equal, good equal to false. Doesn't matter what we do. If they are equal, then global head is global next. And we have started backtracking now. I hope it makes sense. We don't want to return to anywhere because you see, at any point, if I find any truth, then that will cause, like, you see that last test case, 1 and 1 returned true. When it was computed as true. So it returned true. We don't want that because in the next step only a false is existing. I hope it makes sense. So we have solved this question in three ways. One is using extra space. One is modifying structure but without using any extra space. This question is impossible to solve without any extra space and not modifying the character. Uh, not modifying the data structure. Uh, the difference between this and the other is this I am using extra space, but not directly. We are using the recursion stack space. So the interviewer may say that don't use any auxiliary space. You are allowed to use stack space. Okay, let's go to the next question. It says design hash set. Is this linked list related? Okay, hash function. I don't think this has much to do with linked list. Let's skip this question. Hash map also same. Middle of the linked list. I think I don't need to explain you this code. Where can I get to the last code? Uh, Submissions. You see, we have just used that rabbit. Fast is the rabbit, slow is the turtle. That's it. Exact same code. I'm not. This code will be available in the description. We have already used this multiple times. Next is convert binary number to in a linked list to an integer. Okay. Is there any follow-up? No. So extremely easy. We will just traverse, put, and then from the end, like if just let's say I first get a one. So that means two of that power. Next I get a zero. That means that got multiplied by two. And then I add a zero. So of course, if you are doing this directly by array, uh, after storing them in array, it doesn't matter. But I want to teach you something extra, like why, like running creation. Like we are, let's say I get a one, right? That means my answer is one. To the power zero is one. What if I get a one zero? This means my previous answer will get multiplied by two, and I will add zero, so I get two. What if it's 101? Up to this, the answer was two. We multiplied that by two, and we get one. You understand what we are doing is we are left shifting and adding. I hope it makes sense. Like in order to incorporate a new one, we have to left shift and then incorporate. If it is a zero, we don't add anything. If it's a one, we add a one. And then we left shift again. Every time we get a new value. I hope I'm making sense. Like for example, let's say 110 110 0. The value of this is x. I want to know 110 110 110 once. So one extra one. So, you understand that this value is x. right? But this got shifted by 1. So this should be 2x plus 1, which is this one, right? Try to think about it a little bit. Think about left shifts and right shifts. What happens when everything is gets shifted by 1? Like you understand that this is 1. If it gets shifted by 1, it's 2. Again, shifted by 1, it gets to 4, then 8, then 16. What if I get shifted by 1? Let's say this is 1. It gets shifted and 1 is added. That is multiplied by 2 plus 1. 1 gets shifted. That means the entire thing multiplied by 2 plus 1 if we have an 1 in the end. I hope I'm making sense. So we will use this. So into result equal to 0, and I will say uh, p equal to head, and I will say that while p is not null, I will say that res equal to res into 2 plus the value of the p, like let's say that p arrow val, and p is equal to p arrow next, and I will return this. Then res, I guess. Even though I've not solved this question before, but okay, extremely easy question. Of course, the time complexity is linear, nothing interesting. The next 4 questions are unfortunately premium, and I don't have premium, so I cannot really solve those questions. Let's get to the next question. 3507. It says minimum pair removal to sort the array. Okay, you are given a num. Okay, we are given an array. I don't see any use of linked list, but okay. Uh, and I can perform the following operation any number of times. Select an adjacent pair with the minimum sum in nums, and choose the leftmost one. Replace the pair with their sum. Return the minimum operations required to make the array non-decreasing. Basically increasing. You can say that. With the minimum sum in nums, like 3 1 has the minimum sum, okay, and replace it with their sum, okay. Okay, what is the constant sum? 50. Uh, in that case, I can just traverse the array, check which pair has the minimum sum, replace that two numbers with their sum, again an order in complexity, to replace it, and then I check if the array is sorted after that many operations, like complete brute force. Is there a better approach? We want, but the pair has to be adjacent. Otherwise, I could have used a priority queue and taking the minimum 2 elements and then added it up. Hmm. Let's see how the stream is running. What are the topics? Okay, there is priority queue. I don't want to go the brute force way. I don't know why the camera quality has reduced so much. I should take care of this lighting. Wait, okay, fell off for some reason. Okay, okay. I can select every adjacent pairs, push them into a priority queue. So what I will do is, where's the pen? Okay, where did I keep my pen? Just remember. Found it. Okay, so what I'm thinking is, okay, it's causing error for some reason. Yeah. So let's take this array 5, 2, 3, 1. Right? Why is it not showing? I think I should quit quick time player. Yeah, we have 5 2 3 1. What I will do is take 5 2, 2 3 and 3 1. So sum of 5 and 2 is 7, 2 and 3 is 5, and 3 and 1 is 4, right? Now you understand that this is the minimum sum. Uh, so I can replace 3 and 1 by 4. How the minimum sum gets updated now? Uh, 5 2 will still remain 7, but 2 and 4 will become 6. But how will I handle that in priority queue? Do I have any other example? 1 2 2. Oh, it's already sorted. So hmm. Like one priority queue is only helping me to find which is the minimum sum. Uh, I think I can store the indices as well. I will skip this question for now. I don't want to waste time, and I don't think it's much related to linked list. Let's go to the next question. I think it's our first medium question. It says add two numbers. So basically 5 plus 2 7, 6 plus 4 10. We add the carry. 4 plus 3 7 and plus 1 is 8. Okay, I think I've solved this before, but okay. So simple addition. We have two pointers, add them up. If it is carry, first I will do a XOR, like take the first digit, and then I will send it to the next to gets added up, get it added up with the next one. So I will say initially carry is 0, 0, and I will say while L1 and L2. Of course, I have to make new nodes continuously. NH equals to new list node with the value of 0. So I will do is nh dot val is equals to, first I have to do int p is equal to L1 dot val plus L2 dot val. Now I have to check if it is greater than 10, greater than equal to 10. If p is greater than equal to 10, carry equal to 1, and nh dot val equal to p minus 10. nh arrow next new list node the value of 0, nh equal to nh arrow next plus carry. Let's try this. Okay, this will be key. Memory limit exceeded. So we are doing a new list node of 10, 0. Okay, I have to proceed this L1 and L2. But what if one of them gets, are they of equal sizes? No. Okay, I have to check. If I have L1, then I will use L1 arrow val, otherwise 0. If I have L2, then only I use L2 arrow val, otherwise I will use 0. Okay, 7. What is it putting 0 in the end? Wait, 899 000. So there should be a carry, right? Mm, so we have started with a new list node, and now we are saying that 41 and 2, 4, 5, 5, 6, 4, 2. Can I put carry greater than? No. Wait, wait. Okay, if I have carry, Then only I make a new node, right? But in this case, I'm still making a new node. I only make a new node if there is a carry. All right. Yes. Basically, we are only generating for carry if, I mean, we're generating our next node only if there is something available to put. Let me explain you the solution. First, what we are doing is initially our carry is 0. Initially, we made a node with 0 value. Now, and we are keeping a pointer to it. Now, we are saying that if L1 is not empty, or L2 is not empty, or L1 or L2 or carry, any of them has some value, we put that value in P. And we say that if it is greater than 10, there is supposed to be a carry of 1, because the maximum 9 plus 9 can go up to 18. Right? There is no way of carry 2. And the value will be P minus 10, like if there is a carry. And if there is no carry, it's just P and there is no carry. Now we check that if next L1 or next L2 or carry is available, then we make a new node on the side and we traverse to that new node and we will start working on that later, right? And we say if L1 or L2 any of them is available, then we make it proceed. Like sometimes L1 will be available, L2 will not be available. This code will be available again. Next is remove the nth node from the end of the linked list. Is there is a follow-up? Yeah, could you do this in one pass? So for one way is just calculating the length of the linked list and do L minus n and then delete that node, right? But what if we want to do this directly, like in one pass? Like we want to go and let's see how we can do this in one pass. Okay, what we can do is perform a recursion. Let's say the recursion has reached the end. After reaching the end, we will start incrementing a global variable. Okay, one pass is done. Like the last node is done. The second last node is done. As soon as we reach I plus 1 or n plus 1, n is 2. So we are on the third node from the end. What we will do is skip. I hope I have made myself clear. So let me show you my approach. What I will do is say this is the list, and let's say yeah this node like reverse, like I call a recurrence for 0 and say recurrence. So this calls recurrence for 1, this called recurrence for 2, this called recurrence for 3, and this called recurrence for 4, and it has returned. Now we are on this node, right? And let's say n equal to 3. I want to delete the third node from the end. So what I will do is after this is finished, I will increment a global pointer, global variable int pr maybe equal to 0, and then after this is done, after returning, I will do prpt plus plus. So pt will become 1. After this is done, pt will become 2. After this is done, pt will become 3. As soon as pt becomes equal to n, we will make that node next to be that node's next. I hope I'm making myself clear. So we were going to do this only. So int pt equal to 0. Let's say void recurrence. I need the n as well. If head equal to null point. I think we just return pt plus plus and we return. What if I want to delete the first node from the end? If pt equal to n, so you understand that pt equal to 0, pt will become 1, and I want to delete the first node from the end. So I want to go to the second node, right? If I will say that pt, like I will travel 2 steps in order to delete the first node. Say that head tells just pt plus plus, right? So I will just call this recurrence. I hope this works. There is some rev going on. Okay, I have to call this recursion. If head arrow is nils pointer, otherwise I will just do pt++ and call recurrence of head arrow next. Then will be just passed as it is. Okay, but if I want to delete the first node, that means, yeah, I want to delete the first node. Let's remove this test case for now. I will deal with this later. Okay, I wanted to delete that test case. Network error, come on, wrong answer. 1, 2, 3, 4, 5, we have returned. So we are not deleting anything. N equal to 2. If n plus 1 equal to pt. It's to pt plus plus. So just we want to do this pt plus plus only while back propagation. Print head value. Let's try to reverse it. It is the time 1:33. So 4, 3, 2, 1. Yes, it's working. So I will do p plus plus. So 1, 5, 3, 4. Uh, so 1, 5, 2, 4, 3, 3. Okay. If pt equal to, so we have to remove 4, right?